You may want to take out our lessons from previous, or if you have a blank piece of paper, you can do that too. I am going to make a correction of something I said. I'm going to make a correction from something I talked about yesterday. Just to make things simple, I'm going to give you an example with the number set 1, 2, 3, 4, 5, and 6. So you can see exactly what number it goes where. All right. In this number set, what is the median? Once, twice. Yep. Median. Yep. Yes, it would be. So looking at the lowest and highest number, you're literally counting 1 number, 2 number, 3 numbers, 1 number, 2 number, 3 numbers, and you realize, oh, there is no middle number. So that middle number is going to be shared between 3 and 4. So the median, aka Q2, is going to be 3 plus 4 divided by 2, which is 3.5. That dotted line will divide the this one data set into 2 halves. And from here, it is easy to start calculating Q1, Q2, and Q3 because, you know, that dotted line divides it in half. 1 number, 2 numbers. 1 number, 2 numbers. Oh, Q1 is a 2. I don't have to do any calculations. I just can. 1 number, 2 numbers. 1 number, 2 numbers. Oh, Q3 is a 5. I don't have to do any calculations. So far, so good? So that's nothing different from yesterday. Ethan, you with me? You with me? Are you sure? Now I'm going to increase it. What if I have an odd number set? So now I'm doing, oops, 7. So I will have a different Q2, a different Q1, a different Q3. Here we go. Which number is the middle? There are a couple people. Nolan? 4. Yeah, 1, 2, 3, and 4. 1, 2, 3, and 4. There is a middle number. I don't have to do an average. So bam. But here's where it gets a little bit complicated. Yesterday, I said include 4. That's a lie. If this is the median, you do not count the median when you divide the data into left and right. Yesterday, I think I said you have to include the 4 and you have to include the 4 like that. I was wrong. So use this video as a reminder then if you need to, okay? And also proof that I corrected myself, whatever. From here, 1, 2, 1, 2. Q1 is still a 2 and 1, 2, 1, 2. The Q3 is still a 6. It does not involve the 4. The median does not count when you look at the first and last halves of the data set. Why am I telling you this? Well, there's a third scenario, and I don't want you to memorize it. I hope that you'll understand it, but you'll see what I mean once I get to this point. Instead of 7 numbers, I'm going to talk about 9 numbers. And it's an odd number, but the result actually changes a little bit. Again, what's the median? 5. And what did I say about when about the median when I divide it into halves? Does it count as part of the numbers? No. So you are going to ignore that dotted line. And now I have 2 separate data sets. What's the middle number of the first half? Yeah. Yeah. So now suddenly I have to do the average this time. And what's the middle number of the second half? I have to do the average. In other words, if there are 3 different situations you might run into. So the best way to approach this is not memorize all three situations, but tell yourself, whatever the median happens to be, whether you calculated the average or not, it does not count when I separate the data sets to left and right. Okay? We'll see some examples today. Yes, Nate? Yes. So going back to my original example, do you notice how the median is a 3.5? That number does not count when I'm looking at Q1 and Q3. Just whatever you find as a median, it does not count as your halves. Yes? Okay, sure. I'll do that as just as a quick example. Let me erase. So instead of 6, what if I had 5, 6, 7, 8, 9, and 10 numbers? So you know that it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The middle number is 5.5. Okay? Correct. From here, don't count that dotted line. That's your first half, and that's your second half. What's the middle number of those? Yeah. So your Q1 is a 3, and your Q3 is a 8. There you go. Next question that you are going to ask is, why the heck do I care? Again, analyzing data, welcome, is all about presenting the facts in a way that is easily digestible, and how you discuss it is up to you. So we are going to learn a way to present it in a really nice, concise, simple way. Please turn to our new sheet called Lesson 2, Box and Whiskers Plot. Okay, and it looks like this. All right. What you are going to be doing is drawing this shape for me. And it's going to look weird. Sometimes the whiskers are long, sometimes the whiskers are short. Don't worry, okay? You'll get to understand what goes where very soon. Here are some things you have to notice, though. There is a rectangle in the middle, and it is beside 2 little antennas we're going to call whiskers. Okay? The lowest point is the minimum point. It's drawn as a dot. The largest point, we call it a maximum. It is drawn as a dot. In this rectangle, you will see 3 vertical lines. These vertical lines represent your Q1, your Q2, and your Q3. And once we start drawing it in this way, it'll make sense to you. Why are we drawing it this way? Well, we already talked about min, Q1, Q2, Q3, and Q4 being 25% of your data. Here to here is the lowest 25% of your data. Here to here, Q1 to Q2 is the second lowest 25% of your data. Q3 holds the third quarter of your data, and the last whisker holds the highest 25% of your data. In short, half of your data, you'll find it here. The lower quarter, lower piece is found on this end, and the highest piece is found on this end, which means if this was your test, these are the collection of your test marks. What does it mean? Sometimes you get high marks, sometimes you get low marks, but most, at least about 50% of your marks will be found in these boxes. So you're playing basketball. Sometimes you can score really low in a game. Sometimes you can score really high in a game. But most of your games, so 50% of your games, will be found scoring in this box. That's what it is. And you'll see how effective it is when we use Box and Whiskers to compare things. Here we go. To build off of yesterday's lesson and to get practice drawing this box and whisker, I give you a set of data, right? Let's pretend this is the number of points in your basketball game, okay? Tell me, I hope that you'll be able to do step 1, putting them in order, do step 2, determining the quartiles, and do step 3, figuring out the max and min. Once you do so, we will draw a box and whisker plot together. Okay, so you should be able to do step 1, 2, and 3 in a couple of minutes, especially if you've been keeping up with homework. Let's go. All right, keep working on it. I am going to try to catch up to where you are. All right, we've got 3. And then we got 7, 10, 11, 12, 14, 16, 17, and then 18. All right, 1, 2, 3, 4, 5. Wow, that was actually impressive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 numbers. Okay. So please take a look at the speed in which I'm going. I really hope you can keep up with it. This took me the longest. From there, because I counted 12 numbers, I'm going to be counting half of that. 6 this way, 6 that way. It seems that the median is not an actual number that's on the data. I have to calculate. Q2, in other words, the median, is the average of the 2 numbers adjacent to that dotted line. That would be 21 divided by 2, 10.5. Okay, great. Now that we have that done, we haven't finished yet. We're looking at this data set and this data set separately to calculate your Q1. Seeing as how there are 6 numbers, I am going to count 3, 3. Q1 belongs right in between. But I don't think I have to do any calculations for that. A number between 4 and 4, the average of 4 and 4 is 4. And then Q3, I have 3 numbers and 3 numbers. This one it looks like I do have to calculate. Q3 is the average of 14 and 16. If you have a number line drawn in your head, you know that that's going to be a number perfectly between. All right, great. I am going to take this and scroll this down because you're going to be using these numbers soon, okay? I also need 3 and I need 18 for the next section. So rolling down and going to the next page, we have ourselves, let's see, Q1 is 4. I'm having such a hard, oh, there it is. Q1 is 4. Q2 is 10.5. Q3 is 15. My min is 3. My max is 18. Using this, would you please try and draw a box and whisker plot on the first line? I think I gave you too many lines, but for now, let's do a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How to draw a box and whisker plot? Well, first, let's draw the min and the max. Dot, dot.
Oh, yes. I was going to say that the middle was the smallest number, but I noticed that the median was the smallest number in the entire number.
Pardon me?
Why is Q1 4?
Well, we looked at the data, and that was the number that was perfectly between. We calculated it. It's hard to say.
10 and 3.
No, it was like 3, 4, 4, 4, 7, 10. No, 3, 4, 4, 4. Yeah, you're right. 7 and 10. The number perfectly in between this data set was between 4 and 4. So the average of 4 and 4 is 4. Okay, next. Please mark your Q1 as part of your box. Draw a thicker line, vertical line at 4. What is going on? Next, draw another vertical at 10.5, which is going to be between 10 and 11. And draw another vertical at 15. There it is. And then please connect the whiskers like so. And there you have it. Here is a box and whisker plot that is, I think, simple enough to draw because you don't have to do too much math to create it, but also conveys a very powerful message. So let's analyze this just a little bit. My lowest point is a 3, and my highest point is an 18. And just from looking at the numbers, it seems like a big spread. Oh my goodness, 3 is so small and 18 is so big. It seems like a big thing. But if you look at all the other data, half of your information, half of the data comes from here to there. Remember, I had 12 numbers. Out of the 12 numbers, 6 of them come from here. Out of the 12 numbers, 3 all falls in here and 3 all falls in here. Think about it. Every single piece of this whisker plot is 25% of the data. I had 12 numbers, which means 3 of those numbers are here. The next 3, the next quarter, the next 25% is here. The next 3 is here, and the next 3 is there. This is all 100% of your data. And each chunk is a quartile, a quarter.
Wait,
Yeah.
is it so big if it's quarters that it's a quartile?
The word quarter means divided into 4, into a group that has 4, right? It's 1/4. So each of these pieces of a box and whisker represent 1/4 of your data. Well, this has a lot of diamonds. This is one small box and one small box. 25%, 25%, 25%, 25% of your data. Because the lower 25% here has a larger difference. So one of the marks was a 4, another one was a 7, and another one was like a 10. So that not the first 3, but the next 3 had a huge difference. The next 3 numbers didn't have that much of a difference. So it tells you a lot just from looking at this if you know how to read a box and whisker.
You have to be able to figure out which one's not big enough to stick or whatever to mark down.
You try to solve that answer by yourself. Remember how to draw this. You're supposed to calculate Q1, Q2, Q3, and then max and min. Yeah, so that might be able to answer. So here is this example right here may not tell you much. So I'm going to present to you some real life data and see if we can start arguing a little bit. Because remember, The whole point of data analysis is to present the facts in a nice, digestible way that's based on facts. No lying, no bias. It's up to us as human beings to talk about it as honestly as we can. So take a look at this. On your sheet is this little thing, but don't worry about this little thing. What I'm gonna actually get you to do is perform it. So let's first talk. These are actual real life data. Far as the owner's been. Okay, let's talk. Okay, here we go. What I wanted is here. Okay, so here are two basketball players in the WNBA. In the last 5 games, Asia Wilson scored 18, 19, 20, 21, 22. Some of you might want to get your calculators out. Then we have Pia Nurse, who scored 9, 16, 21, 26, 31. I won't ask you specifics. I'll only ask, who do you want on your team? And tell me why. Got a couple people. Marshall? Consistency. All right. So as a coach, what you might want from your player is, no matter how easy or how tough, I want consistency. I want you to be dependable. I give you the ball, I need to know that you will perform no matter what. That's what you're saying. Okay. Anyone else? Based on data, what would you say? Go ahead. Marshall? Sorry, Rehan? Okay. Doing some number crunching. I like that. Anyone else? Right?
I need 4 games, 5 games.
Okay. All right. Sample. Oh, okay. So one person's like, I need a bigger sample size. I like that. Another person's like, it's not just about points. There's more to a basketball game than points. I need more info. Absolutely. There you have it. Now we're starting to talk. Me as data analysis can only present the facts based on the facts. How you interpret it is just as important. Okay, so let's talk. Some people, I think Rohan might have been trying to calculate average, right? But you might have found that both of them actually have the same average. So you can't say one person's better or not based on average. Another person might say, oh, forget average. We've been learning median. What's median? 21. 21, so that doesn't count either. So we need a little bit more. So following Ryan's suggestion, how about I give you some more data? And this is where I need everyone to actually do this. Okay, this is going to be a group activity. Everyone on, let's say, on my right, please do Asia Wilson. Okay, and on my left, would you try Kia Nurse for these data sets? You can check with each other to make sure you're doing it right, but everyone just work on their own. Everyone here, I would like you to, sorry, now that I know that I'm recording, am I actually sharing the right one? Yes. I would like everyone to create and analyze the data based on these 20. Now, I know some of you are like, oh my God, here. Let me get this out. Yes, there are 20 numbers, but as I said before, the part that takes the longest is ordering them from smallest to largest. But if you miss one number, it changes everything. So please don't be careless. Take your time ordering it in the right number and then analyze it based on the 5 key numbers. I'm going to ask you, well, what do those numbers represent? And then I'll ask you to generate a box plot using the number line that's on your sheet. And then I'm going to ask you some qualitative questions like, who's better? Who's more consistent? How did you measure this? And so on and so forth. Okay, so 2 things. Number 1, order this from smallest to largest. So this group right here, order this from smallest to largest. Calculate your min, max, Q1, Q2, Q3. And then using your number line that's on your sheet, draw your box and whisker plot. Now asking you to draw your box and whisker plot, I am going to get you to compare with the person, and we'll talk a little bit more about it. Disclaimer, on your number line, you might want to count up in twos because you won't have enough to reach 39 points. Okay, start at 2 and start counting up in 2 points. Okay, I'll give you, you should be able to do this in about 5-10 minutes. Let's give it a shot. And I will pause. Why is it so hard to pause? Okay, everyone, let's check your answers for your half. For the people that did Aja Wilson, listen up. Oh. For the people that did Aja Wilson, please check your numbers. If you didn't miss any numbers, you should have this as your data, your 5 key points. For Kia Nurse, if you didn't miss any numbers, these should be your 5 key points. Okay? And let's say you made a small mistake, that's okay, it happens. I am the greatest poster child for making careless mistakes in data. Okay? My math teacher in data loved me and hated me at the same time. Here we go. This is what the box and whiskers look like next to each other. Aja Wilson has most 50% of her games. Out of her 20, 10 of her games were scored between 12 to 19. Kia Nurse, out of the 20 games, first 20 games in 2019, 10 of her games, half of her games scored between 12 to 20. So 12 to 19 versus 12 to 20, which one is better? Forget the whiskers, just answer that question. 12 to 19 or 12 to 20, just looking at the box. Why? It was bigger range. So they both have the lower minimum of 12, but Kia Nurse looks like there's a higher chance they'll score 20 points instead of 19, huh? Right? Because out of the 20 games, 10 games scored here, 10 games scored here. But then you start looking at the min and max. Aja Wilson, lowest score was a 15, and her highest ever scoring game was 39. Whereas Kia Nurse, yes, they performed really well, but it's a 26 versus a 2, 1 basket. If you only look at the middle chunk of the data, yeah, Kia Nurse looks a little bit better. But if you consider the entire thing, now the question changes. So let me ask you this. Number 1, who do you want on your team now and why? Yes?
I'll take Aja Wilson because her middle point data is fairly close to Kia Nurse, but her larger is almost way larger than her max, and her min is higher than her.
Okay, that's one way of this. Anyone want to add to that or refute or argue against it? Or anyone want to add to that? Yep, go ahead. Sure. I actually don't know what the average is. I would be curious. True. So one way you can argue, again, I'm playing devil's advocate here. In terms of the majority of their games, out of the 20 games, 10 of them were essentially identical. But the other 10 games, there was a huge fluctuation in the good side of things for Aja Wilson, and not as good for Kia Nurse. Right? But that's just the facts. So now we get to real life and we say, here is the data. As a coach, it depends. Are you looking for a franchise #1, lead the team kind of player? Or are you looking for someone to facilitate and help the actual #1 player of the team. You know what I'm saying? So it really depends on what do you want your LeBron James? Did you want your Kobe Bryant? Did you want a franchise player that will lead the team? Are you looking for the other 4 cast members who will make them even better? Right? Or are you looking for 2 superstars that will work in tandem with each other? I don't know. The statistics is just statistics. It doesn't mean one person is better than the other because there are roles to fill as well. That's what I wanted to talk about. The Box and Whisker plot tells you so much, and it's still just based on facts. How you want to talk about this is up to you. Okay. That is a Box and Whisker plot. Any questions? Food for thought. What do you think is more consistent? And if you have an idea, would you be able to defend it in this picture? Marsh? Why do you say that?
Well, it's not
Okay, so you can talk about because there's a huge swing on that side, it's hard to say that they're consistent. Sort of. You can talk about it that way. Any thoughts? Right? Out of 20 games, if I threw 20 darts on the board, it hits all of that. Or here, if I throw 20 darts on the board, it's going to be closer together. So you can argue that way too. Let me play devil's advocate. You can argue the other way, saying, well, it cares about the consistency though. Consistency is probability. And probability says half of my game, they're identical. Sure, there is some swings here and there, but you know, in terms of whether it's consistent or not, they both have half of their games the same range. So aren't they equally consistent? You can argue that way too. Right? For me, personally, I think I would lean towards A'ja Wilson because consistency-wise, they are the same. But once in a while, I get a better probability, a better result from A'ja Wilson. Right? Most of the time, they will be the same. But once in a while, A'ja Wilson swings to the better. Right? Yes?
But isn't the data kind of skewed because of one outlier?
Oh, outlier. Thank you for being in class, Ryan, because I need to talk about outliers. It's true. Is that 1 point? Is it an outlier? Is it a freak accident? In that one game, did the best player on the other team get sick? Right? And on this side, A'ja Wilson was like, oh, everything is perfect. My passes are perfect. My shot is perfect. Everything is perfect condition that day. Who knows? Right? But we don't know that. All we can do is present the facts. So let's try using the facts to see if that 39-point game is not or shouldn't be included. If it truly is a freak accident based on the facts. And if we can prove it with numbers, well then, goodbye statistic. A'ja Wilson isn't as great as we thought. Okay, let's take a look. Outliers. Taking a look, an outlier is, why is it not loading? That's not cool. Let's see if I can pull it out again. It's still sharing the correct screen, right? Okay, good. Okay, here it is. An outlier. Statistically, an outlier is when the point is so far away from the majority of the other data that we have to kick it out. Well, at that point, you can say, well, how far is too far? We give it a number. Here's how we figure out whether something is going to be an outlier or not. The answer is, please take a look at the interquartile range and multiply it by 1.5. If the point is further than that from the box, then it's an outlier. And that might mean nothing to you, so let's see it in action. Here is a list of distances of each of our planets in the solar system from the sun. It's all measured in astronomical units, AU. Let's start by calculating the quartiles. What is the median? Correct. So let's take it slow. 1.5 plus 5.2 divided by 2 is 6.7 divided by 2. That is 3.35. All right. From there, consider that dotted line. I have already divided the data to the first half and the second half. What is Q1? 1, 2, 1, 2. I am looking for the average between 0.7 and 1.0. Putting that into the calculator, gives us 0.85. And lastly, Q3, (9.5) plus 19.2, can't really see that, divided by 2. I pre-calculated this, 14.35. Okay, so what I'm trying to do is calculate, is Neptune at an astronomical unit of 30, is it too far to be considered part of our solar system? Is it too far that we have to consider it an outlier? Maybe. Which planet was considered an outlier? Pluto, long time ago. But not necessarily because of distance, but because it turns out it's more similar to a moon than it is a planet. So they call it a dwarf planet. But anyways, let's talk about this. What is the formula for IQR? You with me, Nolan? Perfect. And I'm going to do that. That's 14.35 minus 0.85, which gives me 13.5. I pre-calculated this, so that's why I'm moving a little fast. From there, the IQR times 1.5 rule states that if I am greater than that from Q3, then it's way too far away. And then if the data is much lower by that much than Q1, then it's way too far. So in this case, Neptune is on the high end. Let's calculate what IQR times 1.5 equals. That is 13.5 times 1.5. And pre-calculated, this equals 20.25. Okay, so let's test Neptune. What is Q3 plus the 1.5 rule? Q3, in other words, the end of my box, plus the 1.5 rule is the same as saying 14.35 plus 20.25. That gives me 34.6. Is Neptune further than 34.6? No. So it's not an outlier. It stays within my data. It's acceptable. Yep. This one? 14.35. I'm using this number right here. Same Q3. So I'll do a therefore not an outlier. The same can be calculated for if it's too small that it's an outlier, but I won't do that here. And that essentially brings us to the end of our lesson. Do we have any questions? Okay, forget the questions. Let me quickly recap what we've done and ask yourself this. If I give you a data set, can you write it from smallest to largest? Can you calculate the 5 key numbers of max, min, Q1, Q2, Q3? Can you use those 5 numbers to draw a box and whisker plot? And the last one, of course, would be you have to learn how to talk about it, right? You have to learn how to talk about a box and whisker plot based on what you're arguing. And then the last one is outliers. And that one you might need to practice because, yeah, there's a little bit of math involved. You find your Q1, Q2, Q3. You use that for your interquartile range. You figure out what's 1.5 times that, and then you add it to your Q3 or you subtract it from your Q1 to see how far away from your box this data set is, or this data is. So yeah, it's a long process, but I will ask you methodically, can you do this for me? Can you do that for me? So that it's not a big mystery of how to go from one point to another. My task for you right now, would you try this individual practice as well as the homework questions number 1, 2, 3, which essentially gets you to practice what we've done so far with the 5 key points. Okay, that's it. Tomorrow is a small extension to this to see how much you remember. Sorry if I erased it too soon. I put it back right here. Okay. Tomorrow is a small extension of what we've been doing so far. And please note, on Friday, most likely we'll start an in-class lesson or in-class assignment, which will spill over into Monday because you're probably going to be doing stuff with data. Okay. And that may be that's sort of like the halfway point of our data or 3/4 point of our data. We're almost done data. This is essentially as far as we go. So please practice this, knowing that it's good for you. And that's it. That's your expectation.